Today's lesson will be on angles and arcs, other types of angles in circles and outside of circles. We have a few different types of angles and the type of line that intersects them. We start with the tangent and intersected chord. This will work the same as an inscribed angle, which is half the measure of its intercepted arc. There are three places where the lines can intersect. We can have an inscribed angle, so on the circle, inside of the circle, not at the center, and outside of the circle. If the angle is inside the circle but not at the center, we take half the measure of the two arcs added together. If the angle is outside of the circle, we take half the measure of the two arcs subtracted. Here we're looking at just a half a circle idea, 180 minus the angle. An angle that is what's called circumscribed is an angle whose sides are tangent to a circle. In our first example, line M is tangent. Find the measure of the red angle or arc. So the first one, we're finding the angle. The angle is half the measure of its arc, so half of 240 is 120. In the second one, we're given the angle. So if we double 155 by 2, that will give us the arc, which is 310 degrees. First thing we want to find is that angle next to the 94 one, so those are linear. If we subtract, we get this angle is 86 degrees. So if I take half of x plus 80 has to equal 86. Multiply both sides by 2. X plus 80 172 minus 80 so we get 92. Then on the next one we're going to subtract, so half of 100 minus x should equal 35. Multiply both sides by 2. 100 minus x equals 70. Negative x equals negative 30, so x equals 30. In our next example, we have assume that we're at the center of the circle. We also know that the angles across from each other have a sum of 180. So 180 minus 124 is 56 degrees for x. And the other one, same idea. 180 minus 42 is 132 for x. For this one, we're looking for the measure of the arc BD, the portion of the Earth for which the flash is visible. The Earth's radius is about 4,000 miles. So if we know that this is assume that this is tangent to the point at point D, from the radius to the other point, we can use the Pythagorean theorem to help us find the measure of the third side, although we probably may not need that other side. We're asked to find the measure of the arc from B to D. So in order to find the measure of the arc, we need to know the measure of the angle. So one of the ways we could do this is to, given the two sides, is we could just make a right triangle. So once I know the measure of that angle, then the arc is going to be double the measure of, or so the same measure as the angle, because it's a central angle. So I just need to know the measure of that central angle. So we can, we're going to draw it this direction. In this case, the hypotenuse is 4,150. The side is 4,000. We can find the angle and this angle here. So the angle in question would be the angle C right here. SOHCAHTOA ratios will help us. We have opposite over hypotenuse, which is sine. So if we take 4,000 divided by 4,150, it's 0.9639. Inverse sine of that to get the angle. Which is 74.6 degrees. So if that's this angle, the other one will be the same. If we add those two pieces together, we would get 149.2. So if the angle is 149.2, if we assume it's a central angle, then the arc is also 149.2. And that's it for our lesson today.